For as long as we have been human, we have looked up at the night sky and wondered. We see the moon, a familiar silent companion. We see the planets, our celestial neighbors, wandering across the star-strewn canvas, and beyond them, countless stars, each a sun to its own unseen worlds. In all that vastness, through all that time, a single profound question has echoed in our minds. Are we alone? We've sent messages into the void and listened intently for a reply. We have scanned the heavens for any sign, any whisper. We search for patterns, for anomalies, for anything that breaks the silent, natural order of things. It is the grandest of all human quests. This search is, in many ways, a search for light, not just the ancient light of distant stars, but a different kind of light, a managed light, an artificial light. Think of Earth at night, seen from space. These lights declare we are here. So we look out into the cosmos, hoping to catch a similar glimmer from a faraway shore. We're looking for a sign that another intelligence has also conquered its own darkness, stringing lights across its own world. Finding such a light would be the single greatest discovery in the history of science. The universe is overwhelmingly vast, a stage of unimaginable scale. The distances are so immense that light, the fastest thing we know, takes years. Our solar system is like a comfortable, familiar home. We know its layout, its planets, its asteroids, its comets. They all orbit our sun in a predictable, stable dance, bound by its immense gravity. They were all born from the same swirling cloud of gas and dust some 4.5 billion years ago. They are, in a very real sense, family. But every now and then a traveller from a completely different stellar family passes through. These are the interstellar objects, wanderers cast out from their own star systems, journeying through the immense emptiness between the stars for millions, perhaps billions of years. They are cosmic messengers carrying with them secrets of their distant origins. A few years ago we were graced by one such visitor, a mysterious cigar-shaped object named Oumuamua. It was the first we'd ever seen, and it baffled us. It didn't behave quite like a comet. It didn't behave quite like an asteroid. Then came another 2I/Borisov, which looked much more like a conventional comet, and now we have 3I/Atlas. Discovered by the Asteroid Terrestrial Impact Last Alert System, or ATLAS, this object was immediately flagged as special. Its trajectory was all wrong for something belonging to our sun. It was moving too fast, on a path that clearly originated from far, far away in the direction of the constellation Lyra. It was another ghost in the night, a visitor from the great beyond. To study this faint, fast-moving visitor, we needed a very special tool. We needed the James Webb Space Telescope. Often called the successor to Hubble, the JWST is much more than that. It is a marvel of human engineering, a giant golden eye designed to see the universe in a way we never could before. Launched on Christmas Day in 2021, it travelled 1 million miles from Earth to a special point in space where it could unfold its magnificent honeycombed mirror. This mirror, over 6 meters across, is composed of 18 gold-plated beryllium segments, all working together to collect the faintest whispers of light from the dawn of time. The JWST's superpower is its ability to see in infrared light. The universe is expanding, and as it expands, it stretches the light travelling through it. Light that started as visible or ultraviolet from the most distant galaxies is stretched into the infrared spectrum by the time it reaches us. This allows it to peer through massive clouds of cosmic dust that would normally obscure our view, revealing the birth of stars and galaxies in stunning clarity. But this infrared vision is also perfect for studying closer, colder objects like 3I/Atlas. So as 3I/Atlas streaked through our solar system, the JWS pivoted its golden gaze towards it. The observation was scheduled to be routine, in a way. The plan was to stare at 3I/Atlas for several hours, gathering as much infrared light as possible to build a detailed chemical profile of its surface. As the data began streaming back to Earth, scientists at the Space Telescope Science Institute saw what they expected. The faint, continuous spectrum of a cold, rocky body with absorption lines indicating the presence of silicates, perhaps some frozen carbon compounds. It was a fascinating but not entirely shocking portrait of a piece of another world. The object was tumbling, causing its brightness to vary in a regular, predictable cycle as different sides faced the telescope. But then, within the data, they saw it, a series of short, intense, unusually narrow band bursts of light. They were not natural. Natural thermal emissions are broad, spread across a wide range of infrared wavelengths. These signals were sharp, confined to a very specific frequency, almost like a cosmic laser pulse, and they were not random. When you eliminate the probable, whatever remains, however improbable, must be the truth. In astronomy, we look for natural explanations first, but when a signal shows a repeating pattern, a narrow bandwidth and intensity that defies natural physics, the mind wanders to one possibility, that it is artificial. The lights on 3I/Atlas are not just lights, they are structured information. A simple repeating pulse is the most basic deliberate message. It's the cosmic equivalent of a rhythmic drumbeat, a clear sign of intelligence and intent. What could these lights be? One possibility, 3I/Atlas, is an artifact, an interstellar probe sent to survey our star system. The lights could be part of its propulsion system, bursts of energy for course correction or communication beams or scanning beams actively gathering data as it passes. A functioning alien artifact, millions or billions of years old, tumbling through our solar system sounds like science fiction, yet the data forces us to consider it as a genuine, if remote, hypothesis. Before we leap to conclusions about alien civilizations, science demands that we exhaust every other possibility. The universe is a strange and wonderful place, filled with natural phenomena that can mimic artificiality. The history of astronomy is littered with signals that had natural, unexpected explanations. The first pulsars had incredibly regular radio pulses, briefly nicknamed LGM, little green men, later identified as rapidly spinning neutron stars. So what could be masquerading as alien city lights on 3I/Atlas? One possibility, unusual geological activity, tidal heating as it passes closer to the sun, causing periodic eruptions of gas and dust. If eruptions contain crystalline materials, they could catch sunlight at a precise angle and flash toward us. Diagram. Sunlight hits crystals on a rotating asteroid, like the glint off a perfectly oriented crystal. Another explanation, interaction with the solar wind, the stream of charged particles from our sun. 3. I/Atlas might have a localized magnetic field. Solar particles funneled to a spot on the surface, creating a localized aurora. We see auroras on Earth and Jupiter. If the surface rock there fluoresces in infrared when energized, it could produce the pulsed signal JWST saw, a remarkable new celestial phenomenon. Finally, consider instrumental error or an unknown local effect. So, how do we tell the difference? How do we distinguish between a sign of alien intelligence and a clever natural trick? The answer lies in gathering more data and looking for telltale signs of complexity, a natural phenomenon like a geyser reflective crystal. It will flash, but the flash will probably be the same every time. An artificial signal, on the other hand, might contain information. Think of the difference between a lighthouse, which flashes a simple repeating pattern, da-da-da-da-da-da-da-da-da-da-da. Scientists are now meticulously analyzing the structure of the pulses from 3I/Atlas. They are looking for any variation, any modulation within the signal. Are the flashes always exactly the same length? Is the time between them always precisely the same? Is there any substructure within the main pulse? Visual aid, natural vertical bar, potentially artificial. The presence of any patterned variation, something that looks less like a natural rhythm and more like a deliberate code, would be a monumental step towards confirming an artificial origin. It would be like realizing the drumbeat you're hearing isn't just a beat, it's spelling out a message. Another key test will be observing the lights in different wavelengths. A natural thermal event or a reflection is likely to have faint echoes in other parts of the light spectrum. An artificial light source, like a laser or an LED, can be almost perfectly monochromatic. Regardless of the final explanation for the lights on 3I/Atlas, this discovery has already changed something for us. It has sharpened our focus. It has ignited our collective imagination. For a brief moment, the universe has felt a little less empty. The mere possibility that these flashes are artificial has reinforced the profound importance of the search for life beyond Earth. It reminds us that we should not only be looking at distant sun-like stars for signs of life, but also at the strange objects that wander into our own home, carrying messages from afar. It encourages us to build bigger telescopes. It encourages us to build better telescopes and to keep watching the skies with a sense of wonder and expectation. If the lights are confirmed to be artificial, the effect on humanity will be immediate and irreversible. It would be the end of our adolescence as a species. The knowledge that we are not the only thinking beings would likely foster a new sense of global unity. A cosmic perspective that could make our terrestrial squabbles seem petty and small. It would spur a new golden age of exploration. It would spur a new golden age of science. We might even attempt to send a message back. For now, we stand on our lonely shore looking out at the vast cosmic ocean. We have seen a strange light flicker in the distance. It might be a ship from another land, or it might just be a trick of the light on the waves. Wonder, hope,